In section 0.8, we are going to talk about how to find the prime factorization of numbers. Before we move on to prime factorization, we're going to talk about prime numbers. Remember, a prime number is a number whose only two factors are 1 and itself. For example, the only way to get 2 is to do 2 times 1. So 2's a prime number. The only way to get 3 is 3 times 1. So 3's a prime number. 4 wouldn't be prime because we have 2 times 2 and 4 times 1. Okay, 5 is prime because the only way to get 5 is 5 times 1. 6 is not prime. 7's prime. 8 is not prime. 9 is not prime, 10 is not prime, 11's prime because the only way to get 11 by multiplying is 1 times 11. And finally, let's just go with the last one, 13 is also a prime number. Okay, this list can go on, but those are the first 6 prime numbers. Now, we're going to use those prime numbers to help us with prime factorization. Okay. It says, find the prime factorization of the number, and we have the prime factorization of 40. Okay, we're going to find the prime factorization by using trees. So you need to come up with a multiplication fact that gets you to 40 using whole numbers. So I'm going to use the easy one of 20 times 2. Okay. 2 is prime, so I'm not going to make any branches off that number. I'm going to use that number right there. And now I'm going to split that number up by multiplying. So now I have 10 times 2. Once again, 2's a prime number, so I don't make a branch off of that. I just stop. And now I'm going to go back to 10. 10 is 5 times 2. So, right here, both of these numbers are prime, so I can stop. I can't make any more branches on our factor tree. So the answer to this problem of the prime factorization, you just take all these prime factors and list them in a multiplication problem. So at the end here, our final answer is going to be 2 times 2 times 2 times 5. Okay, that's our prime factorization. Now if I'd multiply those numbers together, I will end up with 40. So that right there is the prime factorization of 40. Now let's do the prime factorization of 63. So I have 63. I'm going to break it up. There's multiple ways to do it, but the fact I remembered was that 7 times 9 is 63. Right there, 7 is a prime number, so I'm not going to make any more branches off of 7 because it's a prime number. Okay, now I can make a branch off of that 9. How am I going to get 9? Well, I'm going to multiply 3 times 3. Okay, 3 is prime and 3 is prime, so I can stop. There are no more branches I can make because all I'm left with is prime numbers. So my prime factorization is going to end up being 3 times 3 times 7. Okay, and that's the prime factorization of 63. Okay, now we're going to do the same thing, but it says we want to write the prime factorization using exponents. So let's do the same thing here. We're going to find the prime factorization. Okay, 24 has lots of facts you can use to get to it. I am going to use 6 times 4. So I know that 6 times 4 is 24. 6 is not prime, so it can have a branch. 2 times 3 is the fact I'm going to use for that, and notice both of those are prime, so I'm going to stop and I'm going to circle those. And now this part right here, 4, I can get by doing 2 times 2. Okay, 2's prime, so I'm going to stop right there. So right there, I can't make any more branches because I have prime numbers, So what we're going to end up with is, for our prime factorization, is 2 times 2 times 2 times 3. But notice it said write the prime factorization using exponents. Okay, so how I'm going to use exponents is I have 3 2's here. So I'm going to rewrite these 3 2's as 2, which is my base, to the third power. Okay, there's 3 2's, so I have 2 to the third power times, I have this 3 left over back here, times 3. So that's the prime factorization using exponents. Okay, same idea here. We want to use the prime factorization, okay, of 100, but we want to write it using exponents. So once again, let's use the tree. You can use any fact you want for 100. Okay, I'm going to use 10 times 10. 10 is not prime, so I can make branches off of both of those. So 10 is the same thing as 5 times 2. Okay, both of those are prime, so I'm going to circle them because I know I can stop with those. And this other 10 is going to be 5 times 2. Okay, and that's what I have. So now notice the prime factorization here is going to be 2 times 2 times 5 times 5. Okay? But it says write the prime factorization of the number using exponents. So right here I'm multiplying 2 5's times each other. Okay, since I'm multiplying 2 5's, I can write that as 5 to the second power. Times, now I have 2 2's being multiplied together, and I can write that as 2 to the second power. So the prime factorization of 100 using exponents is 2 to the second times 5 to the second. Now, in section 0.9, we're going to talk about the greatest common factor and the least common multiple. Okay, the reason we're going to talk about this, the greatest common factor helps us reduce fractions, and the least common multiple helps us find common denominators for fractions. Now, in this first example problem, we're going to find the greatest common factor of the pairs of numbers using listing. Okay, so to find the greatest common factor using listing, I need to find all the factors of 45 and all the factors of 81. Okay, now this next step you might do in your head. I'm going to do it off to the side to just show you what's going on. I need to list all the factors of 45. So I'm going to write 45. I know the one fact is 1 times 45. 2 times something won't give me 45. 3 times 15 is 45. 4 won't work. 5 times 9 is 45. 6 won't work. 7 won't work. 8 won't work. 9 works, but it's already there. So I stop. These are all the factors of 45. So I'm going to put that in a list. So I have 1, 3, 5, 9, 15, and 45. Okay, so those are all the factors of 45. Now, I need all the factors of 81. So I know 1 times 81 is 81. 2 won't work because 81's not even. 3 will work. 3 times 27 is 81. 4 will not work. 5 will not work. 6 will not work. 7 does not work. 8 will not work. 9 works, and I have 9 times 9, and since I have 2 9's there, I can stop. Okay, so now the factors of 81 are 1, 3, 9, don't have to list 9 twice, 27, and 81. Okay, so now I have the list of the factors of 45 and the factors of 81. Now my goal is to find the greatest common factor, or in other words, the biggest number that is in both of these lists. So I'm going to say the greatest common factor is, so I'm looking, there's a match, there's a match, there's a match. So those are all the common factors, but I want the greatest one, so the greatest common factor is 9. In this example, we're going to find the greatest common factor again, but this time we're going to do it using prime factorization. So in other words, we're going to make a factor tree of both of these numbers, and then we're going to find the greatest common factor doing that. So I have 64. I'm going to make a number tree for that, or a factor tree for that, and then I'm going to do 20. So 64, I know that 8 times 8 is 64. Okay, neither one of those are prime, so now I have 2 times 4. 2 is prime. Okay, and then here 2 times 2. 2 is prime, so there we go. Now notice we just did 8. This one's going to be very similar. So right here I would have 2 times 4. Okay, 2 is prime, so I'm going to stop and circle it. And then finally 4 is the same thing as 2 times 2. Okay, so the prime factorization of 64 is going to end up being 2 times 2 times 2 times 2 times 2 times 2. Okay, in other words, 2 to the 6th power. Okay, now we need to do the factor tree for 20. It's going to be a little bit shorter. I have 4 times 5 is 20. Notice 5's prime, so I'm going to stop. And now, right there, I have 4, which is 2 times 2. Both of those are prime, so now I can stop. Okay. All right. Now, I have the prime factorization of 20, and I'm going to write that in black below here. So I have 2 times 2 times 5. So in red right here, I have the prime factorization of 64, and in black right here, I have the prime factorization of 20. To find the greatest common factor using prime factorization, you look for matches. So right here, I have one match of a 2. For that match, I just write 1, 2 up here. Okay, I have another match of a 2. For that one match, I write another 2 up here and I multiply it by the other one. Notice, I do not have any more matches, so the greatest common factor of these two is just going to be 2 times 2, which is 4. So the greatest common factor using prime factorization, you find the matches, and for every match, you write that number down and then multiply the numbers you have left. Okay, using prime factorization, we're going to find the greatest common factor. Okay, so once again, you'd have to do the factor tree. So 12 would be 4 times 3, and 4 is broken down into 2 times 2. So I'm going to circle my prime factors here. I have 2 and 2 and 3. So the prime factorization of 12 is going to be 2 times 2 times 3. Okay, let's do 18 here. So 18 is going to be broken down into, I'm just going to do 6 times 3 is 18, so I break it down, and then 2 times 3 is 6. So I'm going to circle the prime factors here. Okay, and notice the prime factorization of this one is going to end up being 2 times 3 times 3. Okay. Finally, let's do the last one in blue here, and we got to do 60. Okay, for 60, I'm going to do 6 times 10. Okay, Okay, 6 is broken down into 2 times 3, and 10 is broken down into 2 times 5. Okay, and all of those end up being prime, so right here, let's just stick with blue. I have 2, 3, 2, and 5. So the prime factorization of 60 is going to end up being 2 times 2 times 3 times 5. Now, notice, once again, we have the prime factorization of 12 right there, we have the prime factorization of 18, and we have the prime factorization of 60. Now, to find the greatest common factor of this, we just look for a match that is in all 3 prime factorizations here. So notice each one of them has a 2. So for that match right there, I write 1, 2 down. Times, okay, I look, there's another match of a 3 in all 3 of them right here. Okay, so I write that 3 down. There are no other numbers that are in all 3 prime factorizations, so our greatest common factor here is going to end up being 6. Alright, what we talked about before was greatest common factor. Factors are numbers you multiply with. Now, in this problem, they're going to ask us to find the least common multiple. To find the least common multiple, you're going to have to list the multiples of each number. Okay, to do that, really, it's the numbers you get when you multiply with 8. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. Okay, I could keep going if I need to. I'm just going to do 5. I may have to continue this list. So those are the multiples of 8. I'm just counting up by 8. Now I'm going to do the multiples of 12. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. 12 times 4 is 48. And 12 times 5 is 60. Or I'm counting up by 12s. Now, you don't have to make your lists this long. Once you see a match, that's when you can stop. So right here, I could have stopped at 24 because right there is my first match. Okay, and your first match is going to be your least common multiple because your first match is going to be the smallest. So in this case, the least common multiple equals 24. In this problem, we're going to show you how to find the least common multiple using prime factorization. So once again, anytime they're talking about prime factorization, okay, you have to make the trees. So for 24, let's just say I'm going to do 6 times 4. Okay, so 6 times 4. Neither one of those are prime, so I need to keep going. 2 times 3, both of those are prime, so I can stop there. And right there, 4, 2 times 2, both of those are prime, so I can stop there. So right there, those are all the prime factors of 24, so I'm going to have 2 times 2 times 2 times 3. Okay, that's your prime factorization of 24. Now, let's do the prime factorization of 30. Okay, the prime factorization of 30, I'm going to break up. 30, let's just say, is 6 times 5. Once again, you can use whatever you want in these factor trees. And then 5's prime, so I can stop there. And then 6 can be broken up into 2 times 3. Okay, so notice that right there is the prime factorization of 30. So I'm going to write that below here in blue. The prime factorization of 30 is 2 times 3 times 5. Now, to find the least common multiple, what you're going to do is you're going to find the matches and the leftovers. How I remember that? M, I need to find the matches, and L, I need to find the leftovers are in least common multiple. So right here, I'm going to find the matches. I have a match of 2, so I write that once. Okay, I have a match of a 3. Okay, so I write that once. Okay, and now I need the leftovers. What's left over after I don't have the matches? And notice, I have left over, I have a 2 left over, another 2 left over, and finally the last leftover I have is down here. And it's a 5. I'll slide over here so I can get it on there. And now, the least common multiple of these two numbers, I just need to multiply it out. Okay, so 2 times 3 is 6, times 2 times 2 is 4. And that 5 doesn't have anybody to work with, so I'm going to bring it down. 4 times 5 is 20, times 6. 20 times 6 is 120, so I'm going to say the least common multiple is 120. Remember, when you have the prime factorization for least common multiple, you are finding the matches first and then the leftovers, and then you multiply them together.